Okay, example 2. This is your first introduction to what's called a piecewise function. And they're scary looking for most people. People look at them like, oh, that looks hard. And then they immediately get that mental block up in front that I have to jump over to get across to you that they're not that difficult. Okay, a piecewise function just means that it's made up of multiple functions. And it's only alive at certain places. So if you take a look at this specific function, I'll try and explain it to you so you can understand what's going on. F of x equals all three of these functions for different values of x. That's what it's telling us. So if x is a number starting at -10 going up to -4, including both -10 and -4 because of the equals, if x is any number that fits that description, the answer is 8. So f of -9 is 8. F of -8 is 8. F of -4, 8. F of -5, 8. F of -3, I don't know because it's not in that interval. Okay, so that's all that means. We're going to use this function here if x looks like that. The second piece goes from -4, not including -4, all the way up to -1, including -1. And it says if x looks like one of these numbers, I'm going to use this function. Notice the first one, f of -2, is between -4 and -1, right? So let's do that one real quick. F of -2 tells me that f of -2 is in this interval. I'm going to use this function. I'm supposed to change x to this number. So minus x plus 5 is what the expression tells me to do. I'm changing x to -2, so it's minus -2 plus 5, which is just 2 plus 5, which is just 7.
So basically that's just your rules to what to do.
Yeah. Over here it tells you if x looks like this, then you use whichever function is next to it.
Okay.
All right? The next rule says, at the bottom, if x is between -1, not including -1, all the way up to 4, including 4, we're going to use the square root of x plus 5. Notice this second problem here. F of square root of 16 is the same as f of 4. 4 is equal to 4, right?
Yep.
So we're going to use this expression. We're going to do the square root of x plus 5. We're changing x to 4. That's the square root of 9, which equals 3. All right, so for numerical ones, it's pretty obvious. Most people have no real big difficulty with the numerical ones because most people can see this number lies there, so I use that function. Or this number lies there, so I can use that function. All right? It's when you get to these weird ones over here that people start kind of thinking, oh, I don't know about this stuff. I don't like it very much. Oh, one point I want to make before I go any further. Notice this function only lives between -10 and 4, so anything bigger than 4 or less than -10 wouldn't count. So if it said f of 5 does not exist, I'd be fine something along those lines because there's no definition for x equals 5. It doesn't tell me what to do.
Okay.
All right? There's also no gaps. I've never seen one with gaps, but what I'm saying is it doesn't say from like 0 to 5 do this, from 10 to 20 do this, and from 100 to 150 do that. They don't have gaps in it. They usually, like, this goes to -4, and then starting at -4, this one has equals, this one doesn't. If this one had equals and this one had equals, which one do I use? I don't know. So they're not going to make them overlap at all. So there's only one place -2 could be, there's only one place 4 could be. But there's usually no gaps and there's no overlapping of those intervals. Now, this one here, f of h. I have no idea what h is, so they give me a little extra information. H is a number between -7 and -5. H could be -6.2, H could be -5.53, H could be -5.00001 or -6.99999. Every one of the numbers that lie between -5 and -7 also lie between -10 and -4, right? This lies completely inside of that, right? Can we all see that okay? If I go all the way down to -7, -7's in there, -6, -5, all those numbers are in there. So all these numbers are in there. So what's the answer to this problem? It's a constant function, the answer is 8. Again, h fits the description of a number that lies between -10 and -4. This is the answer to the function. No matter what the number is in here, the answer is 8, so you get 8. That one was pretty easy. All right. This was a little more challenging. All right. This describes r to us, but we're not doing f of r. We're doing f of r squared minus 5. So I have to know what r squared minus 5 looks like in order to determine where r squared minus 5 lies in these intervals. So watch how I do this. This is a little bit weird, but it's not difficult to do. 2 is less than r is less than or equal to 3 is my interval for r, right?
Yep.
I want to construct this thing out of this middle here. I'm going to start by squaring everything to make r squared happen. So 2 squared is 4, r squared is r squared, 3 squared is 9. The inequality stays true here because if r is between 2 and 3, its square should be between 2 squared and 3 squared, right? Next, it has minus 5, this doesn't have minus 5, right? So I subtract 5 from everything. Negative 1 is less than r squared minus 5 is less than or equal to 4. Now, if you take a look, I have a description of r squared minus 5, which is what I'm doing f of, right? R squared minus 5 is a number bigger than negative 1, but less than or equal to 4, which meets the requirements of that completely, right?
Yep.
It didn't work very well with the highlighter, but it's this one here. So we're going to use this function in order to evaluate it. So I'm going to do x square root of x plus 5, square root of x plus 5. Instead of x, though, I'm going to put r squared minus 5 in there. So again, I'm replacing x right here with r squared minus 5 because that's what it's telling me to do. I'm using this function because that's where r squared minus 5 lives. If I evaluate this, I get the square root of r squared, which officially is the absolute value of r. Let me explain why it's the absolute value of r, and then I'm going to explain to you why it's not going to be absolute value on this specific problem. So if you just saw this generic problem here, you should get the absolute value of r. Here's why. If r is a negative number, and you square it, you get a positive number, right? When you take the square root, you still have a positive number, so you get positive r, right? But r is negative, so you actually have a negative value, which shouldn't be negative. All right? The absolute value of r is ensure that it's positive. All right? So if you're taking an even power of an even, even root of an even power, you're going to get an absolute value of r every time. So, like the 4th root of r to the 8th. Let's go, the 4th root of r to the 12th, let's go that route. You'll get r cubed, absolute value. If the outcome is an odd power, then you're going to have to put absolute value of r's around it. Okay? Now, on this specific problem, I can say it equals r. Here's why. What do we know about r?
It's between 2 and 3?
Between 2 and 3 according to the original directions of r, right? That means it's positive.
Yeah.
So when I get r squared, it's still positive. When I take squared, it's still positive. So I don't need the absolute value of r's around that. But typically, if you do the square root of a square, you're going to get absolute value of r's around your answer. In this specific case, we can go around it because we know something about what r was to begin with. Main idea of this problem, though, is not that little beast there. The main idea is identify where your x value lies in order to pick the right function and then just simply do the functional value for that one. That's how you do a piecewise function. Works every time.